back then. Oh, shoot, we're doing math. I must move these things out of the way. I'm just kidding. I really do feel kind of fine. I mean, a little woozy or, dizzy, but otherwise, I'm pretty great. So, we are going to talk about equations in quadratic form. Quadratic form is just the form where we have ax squared plus bx plus c. It's really nothing very special, and you've seen it a million times. You know what it is just by looking at it. It's the kind of thing that you can factor or use the quadratic equation on or complete the square on. Today, pretty much everything is going to be factorable. Okay, so we're going to start with an example, x squared minus 5x minus 6, which factors into x minus 6, x plus 1, because those are the two numbers that multiply to equal negative 6 and add to equal negative 5. So x is equal to positive 6, negative 1. Okay, but what if we saw something like y to the fourth minus 5y squared minus 6? Well, notice that all of the coefficients in front of the y to the fourth, y squared, and then the number are the same, which means we've done this before. I can factor this just into y squared minus 6, and then y squared plus 1 is equal to 0. So that's a pretty easy way of factoring that. It's exactly the same as you would just factor the kind of the basic quadratic, right? But then what if you also had something like z plus 5 squared minus 5 times z plus 5 minus 6. Again, all of those coefficients, there we go, are the exact same as our first equation in blue, and therefore I can kind of factor it in the same way. Now I'm going to make x equal to z plus 5, right? And once I substitute that x in, I get x squared minus 5x minus 6, which is exactly the same as what we had in the blue, which means that x is equal to 6, x is equal to negative 1, which means z plus 5 is equal to 6, and z plus 5 is equal to negative 1. And if I solve for z both times, I'll get z equals 1 and then negative 6. Don't worry, we're going to do some examples a little bit more slowly. So I'm calling this the method of substitution. Okay, so we're going to substitute one variable in for another. I'm going to make, some variable like y or z equal to some other thing so that I can make this look simpler. So if I have x minus 7 squared, etc., minus 13, what I'm going to do is I'm going to sub x minus 7 is equal to z, so that the equation would become z squared minus 13z plus 36 is equal to 0. So I can factor this into, let's see, two negative numbers that multiply to 36 is negative 9 and negative 4, and those add up to 13. Good, and then that means that z is equal to 9 and 4, which means that x minus 7 is equal to 9 and 4. So then I solve both of those little equations for x, and I end up with x is equal to 16, x is equal to 11. So make sure you don't just solve for z, right, that we go back to the beginning of the problem where we were trying to solve for x. Okay, next problem. Suppose we have 1 plus 3x squared minus 13 times 1 plus 3x. Whew, I'm really out of breath. Must be because I'm a little sick. Anyway, so we have z this time is going to be equal to 1 plus 3x. And if I do that, then I get z squared minus 13z plus 36, which is much simpler. And it's also exactly what we had before. And I know that z was equal to 9 and 4, right? But this time we subbed 1 plus 3x in. So 1 plus 3x is going to be equal to 9. And 1 plus 3x is going to be equal to 4. If I solve both of these equations for x, then I end up with x is equal to 1 and x is equal to 8/3, right? So don't stop at z equals 9 and 4. Keep going and solve for x. Let's try another example where we have something a little more complex looking. But notice that I have like a squared term and then a term by itself and then one without a variable at all. So this is going to be able to be turned into a quadratic, right? A very simple quadratic. So first thing I'm going to do is move the 2 to the other side so that one side is equal to 0. This should always be your goal, get one side equal to 0. And then I'm going to substitute z is equal to 1 over x minus 1. So the whole equation turns into z squared minus z minus 2 is equal to 0, which factors into z minus 2, z plus 1. Okay, so then z would be equal to negative 1 and 2, right? But really, I'm trying to solve for x. So 1 over x minus 1, which is z is equal to that, right, is equal to negative 1. And then the second equation that I get that I need to solve for x is 1 over x minus 1 is equal to 2. Those were my two solutions for z. So I'm going to multiply both sides of this equation by x minus 1 so that that cancels out of the denominator. And I'm just left with 1 is equal to, once I distribute that negative x plus 1. I'm going to do the same thing with the bottom equation. so that I can cancel out those x minus 1's, and then 1 would be equal to 2x minus 2. If I finish solving the one equation, I end up with x equals 0. That's my first solution for x. And then if I add 2 to both sides, 2x equals 3, therefore x is equal to 3 over 2. That's my second solution for x. You'll almost always get 2 solutions, because this is a quadratic. We always get 2 solutions unless one of them is not possible. Okay, for instance, we may have 3 over n minus 7 over rad n minus 6 is equal to 0. 2 things to look out for. We don't want the denominators to be 0, right? And we don't want the radicals to be equal to a negative. Anyway, if x is equal to 1 over square root n, then x squared is equal to 1 over square root n squared, which ends up being 1 over n. Okay, and that's exactly what we see. We see 3 over n. So I can substitute and have it be 3x squared minus 7x minus 6. And if I do this factoring method, I get negative 18x squared. The things that multiply to negative 18 are negative 9 and 2 that also add up to negative 7. And then I'm going to use my box method to factor out what I can. I get an x out, a negative 3 out, a 3x out, and a 2 out. Which means that I can write this factored as 3x plus 2 times x minus 3 is equal to 0. Which means that x is equal to negative 2/3 3. Okay, but that's not the end, right? We have that x was originally equal to 1 over square root n, and I actually want to solve for n. So 1 over square root n is equal to negative 2/3. Now let's take a look at that there. Well, a square root cannot equal a negative number, right? 1 over square root n cannot be equal to a negative. So I eliminate that in solution entirely. It goes out, goes away, it goes poof. And then for the second one, I just multiply both sides by rad n, and then divide both sides by 3, and then square both sides to get n is equal to 1/9. There's only one solution in this case because the other one was not possible. Good luck on your homework and have a great day.